Alrighty, example 3, and I made this one up. So suppose the profit function for a product is linear and that when 105 units are sold, the profit is $100. And when 125 units are sold, the profit is $200. Write the equation for the profit function and determine the number of units the company must produce and sell to break even. And so we're trying to write an equation. The first thing we look for, again, is do we have the y-intercept? And in this case, we do not. So yay, we get to use the point slope formula. Y minus y1 is equal to m minus times x minus x1. And as always with this, we do need three things. We need a y1 value, we need the slope, and we need an x1 value. So to get things kicked off, our slope is going to be y2 minus y1 over x2, that's a terrible looking 2, minus x1. We're going to roll with it though. And the 2 points that we were given are 105 units for a profit of $100 and 125 units for a profit of $200. As always, labeling x1, y1, x2, y2. We'll plop those values in, and this time I am going to remember to put my fraction bar with my minus signs in first. So y2 minus y1 is 200 minus 100. x2 minus x1 is 125 minus 105. Of course, I'm going to give that to Wolfram and let Wolfram handle it for me. Oops, and that disappeared. Okay, there we go. Wolfram doing a disappearing act. We have 200 minus 100 over 125 minus 105. And we are going to get the result of 5. So our slope is 5. And using the point slope formula, we can go ahead and throw our information in there. So for part A, which asks for a profit function, this is going to be a funky looking profit function. We are going to have y minus 100 equals m, which is 5, times x minus x1, which is 105. Now again, from this, we can see that the marginal profit is 5 because that is the slope, and that's located right there. But we have no idea what the y-intercept is, so let's go ahead and feed this to Wolfram and get a y-intercept out of it. So we will have y minus 100 is equal to 5 times x minus 105. Going down to alternate forms, that's what we're looking for to get our slope-intercept form. This is going to be y equals 5x minus 425. So for a profit function, we get 5x minus 425. And we are asked to determine the number of units the company must produce and sell to break even. So I'm going to add to this a little bit. We're going to change y to p because this is our profit function. And remember, we need to remember for part B that break even occurs when cost is equal to revenue or when profit is equal to 0. And we can use either one of those depending upon the information we have. Well, in this case, we do not know anything about the cost and we do not know anything about the revenue. So I cannot use cost is equal to revenue because I do not have them. What I can use is profit is equal to 0. So we'll take our equation, p equals 5x minus 425, and we are looking for when is the profit going to be 0, because that will tell us how many units we must produce and sell in order to break even. And again, anything that we make past that is profit, and that's good. That's money that we make. But we need to know, when is profit going to be 0? And again, I'll speak to this negative 425 that's hanging out here. That is an example of the fixed costs. And so this is money that gets paid uh, before any units are produced and sold. And so you're going to see the fixed cost actually sort of creeping up at the end of a profit function. As we do that, our answer is x equals 85. And so the company must produce and sell 85 units to break even. If they produce and sell 86, then they start making money. And if they produced 86, they would make $5. If they produced 87, they would make $10. 88 would be $15. And so again, this profit function has a negative value sticking off of the end because there are costs that we have to pay before we ever begin producing anything. Again, like the rent, the electricity, the water, that sort of thing. So with that, that's it for this one.